Hi, hello children, how are you all? Welcome back to my class. In this class, we are going to start your new lesson of science, that is motion and time. So children, you are very familiar with the word time, isn't it? So even our daily activities are based on the time. So children, in this lesson, we are going to study about what is motion, slow or fast, speed, measurement of time, periodic motion of simple pendulum, units of time and speed, distance, time, graph. Okay, so let's start with meaning of motion. So children, look around and you will see so many things moving. The hands of a clock ticking constantly, the blades of a fan rotating, vehicles running on the road, people's eyes blinking, and many more. Even the air around us, though seemingly steady, has particles in it that are always moving, isn't it? And you observe the dust particles moving when sunlight enters the house through a window, isn't it? So these all are examples of motion. So children, if an object keeps on changing its position with the time, it is said to be moving or in motion. Okay, so when a car is not moving, it stays in the same position at a particular time. When it starts moving, a change is observed in its position with respect to time, isn't it? So what is motion? If an object keeps on changing its position with time, it is said to be motion. Okay, so children, there are three types of motion which you have learnt in the 6th standard. Do you remember? Yes, rectilinear motion or straight motion, circular motion and the periodic motion. Yes, so what is the meaning of straight line motion? When objects moves along a straight line, such motion is called a straight line motion or it's called a rectilinear motion. Okay, for example, vehicle on a straight road, march past of soldiers in a parade. Yes, so what is circular motion? Yes children, what is circular motion? When an object moves in a circular path, such motion is called circular motion, isn't it? For example, electric fan, hands of a clock. Yes, then what is periodic motion? An object repeats its motion after some time. This type of motion is called periodic motion. For example, motion of a pendulum, strings of a guitar. Okay. Our next topic is slow or fast. So children, what is the slow or fast? If one object covers a particular distance in less time and another object covers the same distance in more time, then the first object is said to be a moving faster. Suppose here is a car, we'll give a name here A, B. Here is the first car and this is the second one car. Okay, so if one object, this is the first object or it's a car, okay, covers a particular distance, it's cover a particular distance in less time. Okay, and another object covers the same distance more time. Suppose this is the first one object, it took 2 hours to complete 15 kilometer of distance. Okay, and this is second object, it took 4 hours to complete 15 kilometer. See here, the distance is same, isn't it? So here one object covers a particular distance in less time, that is in 2 hours. In 2 hours it completes 15 kilometer. So in another object, it covers the same distance. Okay, it covers the same distance, that is 15 kilometer from here to here, but it took lots of time. It takes 4 hours. So that object is said to be slow. Okay, so if one object covers a particular distance in less time and another object covers the same distance in more time, then the first object is said to be a moving faster and the second object it is moving very slowly. Understood children? Here two things you have to remember, that first is particular distance and same distance. Okay, if one object covers a particular distance in less time and another object covers the same distance in more time, then the first object is said to be faster and the second object is called slow. Okay, understood what is slow or fast? Okay. Now children, let's move with another topic of this lesson, that is speed. What do you mean by speed? So the distance traveled by an object in unit time is called speed. Okay, so the distance covered by an or traveled by an object, it may be a car or bus. So a distance traveled by an object in unit time is called speed. See here, when we say that a car is moving with the speed of 50 kilometer, okay, 50 kilometer per hour, 50 kilometer per hour. So when we say that the car has a speed of 50 kilometers per hour, we usually consider only the total distance covered by it in 1 hour. Yes, so here per kilometer per hour means 1 hour. So we do not bother whether the car has been moving with a constant speed or not during that hour. Okay, so that is called the speed. So here one car is moving with the speed 50 km per hour, or another car is moving with the speed of 80 km per hour. Okay, which is a fast here? This one with the same distance. Okay, so the distance traveled by an object in unit time, in the unit time is called a speed. You know, this is units, isn't it? So hours, minutes, kilometers. So the distance traveled by an object in unit time is called a speed. A slow moving object is said to have a low speed, and a fast moving object is said to have a high speed, isn't it? So there is a one formula to calculate the speed. So that is total distance covered divided by total time taken. Total distance covered means this is 50 kilometer per hour. R, this is R. Here we are showing R, means that is the total time taken. So what is the formula of speed? Total distance covered, that is 50 kilometer divided by total time taken. It may be 1 hour, 2 hours, 3 hours, etc. Okay. Next is types of speed. We are having three types of speed. First one is uniform speed, second one is non-uniform speed, and third one is average speed. Okay, let us see one by one. The first one is uniform speed. If an object moving along a straight line with constant speed is said to be in uniform speed. So see here, if the object is moving with a straight line with a constant speed, it is not changing its speed. Okay, if the object, you can take example of car, if it's moving along with a straight line with a constant speed, it's not changing its speeds. Okay, suppose in 15 minutes, in 15 minutes it is traveling, in 15 minutes it's traveling 10 kilometer. Okay, in 15 minutes, in 15 minutes you can take 4 kilometer. Okay, in 15 minutes if you're traveling 4 kilometer means what? It is a constant speed. It's said to be a uniform speed. So if an object moving along a straight line with constant speed is said to be in uniform speed. Okay, speed. Here we are having three types of speed. So let us study one by one. First is uniform speed. If an object moving along a straight line with constant speed is said to be in uniform speed. Okay, so when the object travels a fixed distance, okay, if when the object travels a fixed distance in same time gap, it is said to have uniform speed. For example, in one if a car travel 1 kilometer in 1 hour, okay, 1 kilometer in 1 hour, 2 kilometer in 2 hour, 3 kilometer in 3 hour, means when the object travels a fixed distance in same time gap, it is said to have uniform speed. Okay, next is non-uniform speed. If the speed of an object moving along a straight line keeps changing its motion, it is said to be in uniform speed. Okay, so if the speed when an object covers different distance, okay, if the when the object covers different distance, different time gap, it is said to be non-uniform motion. Suppose a car is traveling from here to here, it is taking 15 minutes. If you're taking 15 minutes, okay, suppose here a car it is taking 15 minutes to travel the distance from here to here. Okay, and the same car, it is taking 2 hours to travel the distance from here to here. So when an object covers different distance, the distance is different here, isn't it? The distance is different here with different time gap. Here it is 15 minutes and here it is 2 hours. So that is called a non-uniform speed. Okay. Next, third one is a average speed. The total distance traveled by an object divided by the total time taken by the object is called its average speed. Average speed is nothing but the here formula of speed. That is what we use to calculate the speed. So here the average speed is the total distance traveled by an object divided by time taken. For example, if the car is taking 15 kilometer, if it is taking 15 kilometer, okay, if it is traveling 15 kilometers with the time 2 hours. Okay, so here you can see the total distance. This is the distance and this is the time taken. So the average speed, the total distance traveled by an object divided by the total time taken by the object, it is called the average speed. Okay, understood children? Our next topic is measurement of time. You might have thinking that it is of small children's topic. Yes, measurement of time that you have learned when you are in second or third standard. Yes, so here, but here also you are having this one, so we have to learn it. Okay, so measurement of time. So children, in the olden days, okay, in the olden days, our ancestors, they used to measure the time by, see here, if there is a morning, means when there is a sun rising, they will find that there is a morning. So they found that the sun rises every day in the morning. Okay, the time between one sunrise and the next was called a day. Here, day and night, they used to calculate by the time between sunrise and the sunset. Next, month. A month was measured from one new moon to next new moon. That is 1 month. Okay. Next, a year was fixed as the time taken by the earth to complete one revolution of the sun. So that will be considered as a year. Okay. So that time they were not have a calendars like us. They were not having the wall clocks, watches like us. Right. So that time the people, our ancestors, they used to measure the time like this. Okay. After that, there are some devices have been invented. For example, sundial. Okay, this is called the sundial, which is used to measure the time with the help of the sun. Okay, next is, this is called the sand clock. Yes, this is called the sand clock. Nowadays you will find it easily. Now we are using it as a show pieces. Yes, so here can you see here this sand? Okay, it takes, maybe it usually takes 1 hour. When it fall on here, when it fall here, it takes 1 hour, means 1 hour is completed. Okay, and here children, can you see here, this is called the water clock. Here it is having a hole. When the whole water is empty from this container, means the 1 hour, means it is 1 hour. Okay, next is, afterwards we are having the clocks, isn't it? This is called the pendulum that we are going to study here. Okay, this is called the simple pendulum. Afterwards, now we are having a, what we are having? Yes, we are having a electric clocks, isn't it? Digital clocks. Yes, now we are having digital clocks also. So these are the time measuring devices. Okay. Our next topic is periodic motion of a simple pendulum. So children, periodic motion, you know it, right? So periodic motion of a simple pendulum. So this is called the pendulum. Here, can you see here? Yes, so this is called the simple pendulum. You might have seen in your house the pendulum clock. Yes, so this is called the pendulum. Okay, so a simple pendulum consists of a small metallic ball. Can you see here? Consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. Okay, and the metallic ball is called a bob. So this is called the metallic ball, this is called the bob. Okay, here it is a bob, it is called the bob. Okay, when the bob of the pendulum is released after taking it slightly one side, it begins to move to and fro. Okay, so this motion, the motion of the pendulum like this is called the to and fro motion. Okay, this is called the to and fro motion. So when the bob of the pendulum is released after taking it slightly to one side, it begins to move. So this is called the to and fro motion. Here you can see to and fro motion. Okay, so first is the to and fro motion of the pendulum is called as oscillatory motion. So what is oscillatory motion? The to and fro motion of a simple pendulum. This is a simple pendulum, right? So the to and fro motion here, the to and fro motion of this pendulum is called the oscillatory motion. The next is time taken by the pendulum bob to complete one oscillation is called its time period. What is this oscillation means? When children, suppose this is the A, okay, and this is B, here you can see, and this is the O. Okay, so when it's bob starting from its mean point, this is a mean point, that is O. Okay, and moves to A, then again it comes to B, and again back to O. This is called the one complete oscillation. O to A to B, and again B to O. So the pendulum also completes one oscillation when its bobs moves from one extreme position, extreme position A to the other extreme position B, and comes back to mean position, that is O. Okay, so the time taken by the pendulum to complete one oscillation, so that is called its time period. That is called its time period. Understood, children? So what is oscillation? When this bobs moves from the one extreme position A, then to B, then again come back to its mean position, that to O. So that is called its one complete oscillation. So the time taken by this pendulum to complete one oscillation, okay, to complete this is pendulum from one oscillation from here. So this is called the time period. Understood what is time period? Okay. Our next topic is units of time and speed. Okay, so children, here the basic unit of time is a second. The basic unit of time is second, and its symbol is S. Then minute, MIN, hours, HR. Okay, these are the units of time. In the same way, the speed also having its units, such as here meter per second. Okay, it will be read as a meter per second, M bar S. Then meter per minute. Okay, meter per minute. Then this will be read as a kilometer per hour. Kilometer per hour. Okay, and children, you have to remember is that the symbols of all units are written in singular form. Okay, for example, 50 kilometer, not 50 kilometers. It is wrong. Okay, you have to, it has to be written in the singular form, like 50 kilometer, not 50 kilometers. 80 centimeter, not, okay, 80 centimeter, not 80 centimeters. This is a wrong form. Okay, you have to read it as a 50 kilometer and 80 centimeter like this. Okay, you have to read it in a or written in a singular form. Next is formulas of speed, distance and time. Okay, let us see the formulas. So children, here what is the formula of speed? Distance traveled divided by time taken. Next, to find the distance of an object, what is the formula for that? Speed into time. Okay, and to find the time of an object, so what is the formula here? Distance divided by speed. You have to remember all these formulas. Okay, speed is equal to distance divided by time. Distance is equal to speed into time. Time is equal to distance divided by speed. Okay. Odometer and speedometer. Okay, children, you might have seen a meter fitted on top of a scooter or a motorcycle, or similarly on the dashboards of cars, buses. Yes, so here one of the meters has a kilometer per hour written at one corner. So that is called the speedometer. Okay, first we'll study about the odometer, then we'll go for the speedometer. So children, the meters can be seen on the dashboard of the cars, buses. So those are called the odometer and speedometer. Odometer means it is a device which measures the distance traveled by a vehicle in meters or kilometers. Odometer means it is a device which measures the distance traveled by the vehicle. Suppose you have purchased a new vehicle, from that time to till now, okay, how much the distance have been traveled by that vehicle. Okay, so that is called the odometer. The odometer shows the distance traveled by a vehicle. Okay, next is speedometer. Here you can see this type of things you will find in the car or buses, isn't it? So here it is there. This is odometer and this is a speedometer. Speedometer means it is a device which is used in vehicles which measures the speed in kilometer per hour. Okay, so the speedometer, it is a device which is used to vehicles which measures the speed. Okay, at what speed you are running your vehicle, it shows the speed. So that is called the speedometer. Understood what is the difference between odometer and the speedometers? Odometer shows the total distance traveled by your vehicle, whereas the speedometer shows the at what speed you are running your vehicle. So it measures the speed of your vehicle in kilometers per hour. In kilometers per hour. Okay, so here you can see, children, you can see kilometer per hour. Okay, yes, our next topic is a distance time graph. So children, when you heard this name graph, it is very familiar to you. In the maths you have learnt it. Yes, so we find different types of graphs, such as a bar graph that shows the runs scored by a team in each over. Yes, in the cricket, while watching the match, you might have seen the bar graph, which is like this. Yes, the bar graph. This is a bar graph. Then you will have a pie chart like this. Yes, pie chart. Especially we'll see in the while showing the composition of air. Then you will have a line graph. Okay, a line graph is like this. Line graph. We'll get the dots here. Okay, line graph means it is usually see the change in the weight of a man with the age. Okay, this is called the line graph. So in the same way, we are having a distance time graph to see the distance of a object along with the time. Okay, so children, first you have to take a graph sheet. You know that graph sheet. Yes, or a graph paper. You have to take a graph paper. The graph paper like this. Yes, here. You will find the such type of graph paper. Yes, okay. So first what you have to do, you have to take your graph sheet. Then you know that it is having a, yes, it is having a two axis. That is, here it is a x axis and this is a y axis. Yes, so here in the right side you will get the positive values and here you will get the positive values of y. Here we will get the negative values of x and y. Isn't it? We just need a x and positive values of x and y like this. Okay, then here. Okay, now let us see how to draw the distance time graph. Okay, for that purpose you may need a such kind of table. You may need this type of values, okay, to draw in the graph sheet. So children, here this distance time graph should consist of here should be a time and here it is a distance. You can see here it is a distance and here it is a time, isn't it? Okay, so here first what we will do is that first we are going to see the axis. This is x axis and this is y axis and this is the origin, that is O, OX, on the OX we are having the time, and on the OY we are having the distance. For first we have to write the scale. Here you can see I have written the scale here. Okay, so scale on the x-axis, what you are going to write here? You are going to write the minute, isn't it? So here it is having a, this each box is of 1 centimeter, you know it. Yes, this is 1 centimeter, 2, 3, 4, 5 like this, and here 1, 2, 3, 4, 5 like this, isn't it? So 1 centimeter, your scale should be on x-axis. On x-axis 1 centimeter is equal to 1 minute. Here you can see we are having the time in the minutes. So 1 centimeter is equal to 1 minute, and on the y-axis 1 centimeter we will consider as a 1 centimeter. Okay, 1 centimeter is equal to 1 kilometer. Here the distance is given in the kilometer. So here on the y-axis 1 centimeter is equal to 1 kilometer. This will be your scale, and you have to write your scale here. Okay, and your scale should be here. Okay children, okay. Now let's see how to draw a graph. Here we are having the values. Can you see the values here? Yes. So here on the x-axis we have to write the minutes. So see children, here we will going to write it. Okay, we will start from 0, then 1, and this will be a 2, this is 3, this is 4, this is 5, like this. Okay, next distance. Where is the distance? Here. So 1, 2, 3, 4, 5, 6. Okay, so this is the readings which we have written on the graph sheet. Okay, now let's draw the graph. So first here you have to see the time. In the 0, the car, okay, will take the motion of the car. The car on the 0 minute, it is covered the 0 distance, so it should be here. Okay, we'll put the mark here. Next, come to the second one. So the car in 1 minute it travel the distance of 1 kilometer. So where is the 1 minute here? Here is a 1 minute. Here is a 1 minute, and it travel the distance of 1 kilometer. So where is 1 kilometer? Here is a 1, means this is a distance, this is a time, this is a kilometer, isn't it? So we'll draw one dot here like this. Okay, next come to the next one. In 2 minutes, in the 2 minutes it travel the distance of 2 kilometer. Where is the 2 minute? Here is a 2 minute. And where is the 2 minute? Here 2 minute is there. And where is the 2 distance? Here 2 kilometer distance. Here is a 2 kilometer distance. So we'll take this here. Yes. So from here timing is 2 kilometer and distance is 2 kilometer. And from here 1 kilometer, 1 kilometer. Okay. Next. Okay, next is third. In 3 meter, okay, sorry, in 3 minute, that car has traveled 3 kilometer. In 3 minute, where is 3 minute? Here. In 3 minute, it travel the distance 3 kilometer, means here. Yes, isn't it? So here it is like this. Your point should be very small here. Okay, next. In 4 minutes, it has traveled the distance 4 kilometers. So where is 4? Here it is 4. And where is the 4 from here? Here it is a 4. And here is a 4. Okay. Next, in the same way, in the 5 minutes, it has traveled the distance of 5 kilometers. So 5 minutes, 5. So here it is there from here, 5. So children, here you can see that the car has traveled in 1 minute, it has traveled 1 kilometer. Yes. Second, in 2 minutes it has traveled the distance 2 kilometer. In the 3 minutes it has traveled the distance 3 kilometer. In the 4 minutes 4 kilometer. In the 5 minutes 5 kilometer. After that you have to join all these dots. Here we got the dots. Yes. Here we got the dots. Do you remember? Yes. Here we got the dots, isn't it? Now you have to join all those dots. Okay. So here like this you have to join. Your line should be very straight. You have to use the scale. Okay. So children, here you can see that this is the distance time graph for the motion of a car. It will shows you that at what time the car has traveled. Okay, so this is the distance time graph for the motion of a car. If the distance time graph is straight line, it indicates that the object is moving with the constant speed. It is moving with the constant speed. However, if the speed of the object keeps changing, the graph can be any other shape. Okay, here I will show you. If it changes distance, okay, we are having to the shape of the distance. Here we are having three types of shapes of the distance. First one is a straight line parallel to the time axis and the curve shape. Okay, first is straight line, which we have done here. This is a straight line graph. This is a straight line. This is a straight line distance time graph. Here you can see the line is straight here, isn't it? So this is called the object has a uniform or a constant speed. So this is a straight line graph, and parallel means like this. Parallel means like this. Okay, parallel means like this, means it is stationary object. Stationary means the object is not moving here. Okay, the object is not moving here in the parallel one. So this is the object. Here, curve shape in the sense, we will find the two curves here. Okay, curves means the object has a non-uniform speed. Non-uniform speed means what? Yes, non-uniform speed means what, children? Now just I told you. What is the non-uniform speed? Yes, if the speed of an object moving along a straight line keeps changing. Yes, so that is called the non-uniform motion. So here the graph should be like this, because it is a non-uniform. It may be change in the distance or maybe in the time. Yes, so this is called the curve shape. We will find the three types of shapes of the graph, that is straight line, parallel and the curve shape. These are the three. 1, 2, 3. Okay, children, do you understood how to draw a time graph? Yes, distance time graph. It's very easy. You just need to follow the table here. Here you have to write the time, and here you have to write the distance. Okay, on which time, at what distance has traveled, you have to write. That's it. Okay, and you will get the graph. It may be varies. Okay, so children, here there is one more graph. In the graph paper, suppose the total distance covered by a bus is 80 kilometer. Okay, the total distance covered by a bus is 80 kilometer, but in the graph sheet you can't have a 80 centimeters long sheet. You are not having a 80 centimeters long sheet, isn't it? So that time what you have to do? Then at that time you can take it as a, you have to just some of the points to be kept in the mind while choosing the most suitable scale for drawing a graph. Okay, your graph should be within that paper, within that sheet only. You are not having a 80 centimeter long sheet, isn't it? That time you have to be very careful that you have to see the difference between the highest and the lowest point. You have to see the difference between the highest and the lowest values, then the intermediate values each quantity, so that with the scale chosen it is convenient to mark the values on the graph. Okay, and to utilize the maximum part of the graph sheet on which the graph is to be drawn, then you can, at that time you can take the scale as one. This is x axis and this is y, isn't it? So on x axis you can take 1 centimeter is equal to 1 centimeter is equal to 6 minutes. You can take 6 minutes like this. Okay, you only have to divide it. Okay, for that here we are having, from here to here, here you can see 8 o'clock, and here it is nothing is there. Here 8:30, 9, 9:30, 10. Okay, like this you can divide. You have to think about it. Next, on the y-axis you can take, that here 10 kilo 1 centimeter is equal to 10 kilometer. Okay, here you can take as a 1 centimeter is equal to 10 kilometers. Then it is possible you can take a 80 kilometer distance on the graph sheet. Okay, so So children, in this lesson you have learned the what is motion, then the types of motion, what is slow and fast objects, then you have learned the then what else you have learned, what is speed, the formula of speed, then you have learned the simple pendulum. Yes, and you learned how to draw the distance time graph, then you have learned the different shapes of the distance time graph. Isn't it children? So hope you understood all the concepts very well. Okay.